BVS Pragathi channel welcomes you. In this session, let's have a look at cascade amplifiers. There are some more features which we should discuss. So if F1 is lower cutoff frequency and F2 is upper cutoff frequency, the bandwidth is F2 minus F1. If n stages are connected in cascade, F2 naught is equal to F2 into 2 to the power of 1 by n minus 1 to power of half. And F1 naught is equal to F1 by 2 to the power of 1 by n minus 1 to the power of half. So n is number of stages. So we see that as n increases, what happens? F1 0 increases, F2 0 decreases. So total bandwidth is F2 0 minus F1 0, which means bandwidth decreases. Decibel is the measure of voltage, current, power gain in logarithmic terms. Gain of signal varies with input. It is called amplitude distortion. So the power at minus 3 dB point of frequency response of any amplifier is half. And the voltage gain of an amplifier at minus 3 dB point is equal to 0.707. Okay, and let's also discuss about now negative feedback amplifiers. And this is a negative feedback amplifier. A negative feedback amplifier, we see that a amplifier of gain A is fed back with a feedback factor beta, where beta is the feedback factor and ZL is the output, S is the input source, A is the input, AFB is the feedback voltage. So what is AFB? AFB is equal to A by 1 plus A beta when negatively fed. Beta is called feedback factor. Beta is equal to EFB by E naught. Now you know that this EI is equal to ES minus EFB. Okay. Now what is EFB? EFB is equal to beta into E naught. Substitute that. Now you get, see, EI is equal to ES minus EFB. That is what we have seen. And we have seen beta is equal to EFB by E naught. And what is gain? A is equal to E naught by EI. So substitute AEI by E for E naught. Rearrange terms, you get EI by ES equal to 1 by 1 plus A beta. So AFB is equal to E naught by ES. Now E naught by EI into EI by ES. E naught by EI is A by 1 plus A beta. So gain with feedback is A by 1 plus A beta. We see that gain with feedback is less than gain without feedback by a factor 1 plus A beta. So if gain decreases, what happens is stability increases, bandwidth increases, noise is reduced, there's less frequency distortion and reduction in harmonics. So let's have a discussion, let's have a further discussion of various types of feedback circuits. So let's understand the terminology. When we say when we say that the input is seriously fed, if it is series feedback circuit, it means voltage is fed back. If it is parallel feedback circuit, it means current is feedback. At the output, if you are saying it is series derived, it means current is derived, and if it is parallel derived, voltage is derived. Now in series feedback, input impedance increases, and in parallel feedback, input impedance decreases. Whereas in series derived, output impedance increases, and in parallel derived, output impedance decreases. So what is series derived? At the output, when you say it is series derived, you are deriving current. So when you are deriving current, you need to have a high impedance so that the current does not find a path to the ground, rather it goes to the next stage, okay, like this. And similarly, if it is parallel derived, they should be low so that you get a voltage because you measure it between some point at ground, right? Okay, emitter follower is an example of series fed and parallel derived. Why? The input is taken at the base, okay, base is lightly doped. So you have high input impedance. High input impedance means what? Series feedback. And at the output you have low output impedance. That means parallel derived. That is, emitter follower is an example of series fed and parallel derived. So high input impedance because base is the input, low output impedance because emitter is the output. Now there's a problem statement. The problem statement is that the open loop gain is equal to 1000 plus minus 200. And amount of feedback 1 by 1 plus A beta is minus 40 dB. So what is 1 plus A beta? It is equal to 20 log this. So you get 100. AFB is equal to 1000 by 100. Okay, 1000 by 100. A by 1 plus A beta, right? So 1000 by 100, which is equal to 10. DAFB by DA. DFB by A is equal to DA by A into 1 by 1 plus A beta. What is DA? The differential the variation in gain might be 200. Okay, so 200 by the actual gain, which is 1000, into 1 by 100, which is DAFB by A is equal to 0.002. So what is DAFB? DAFB is equal to DAFB by A into AFB. If the feedback voltage is 10, right, that is the feedback factor is AFB is equal to 10. Feedback gain is 10. So 0.002 into 10, which is equal to 0.02. Now let's have further discussion about various types of amplifiers. Okay. So here is various types of amplifiers. So when you call it as current amplifier, it means it's a current shunt amplifier. In that situation, it is a parallel fed series derived. In that case, Ri is 0, R0 is infinity. When you say voltage amplifier, it is a voltage series amplifier and it is series fed parallel derived. When it is series fed, the input you are seeing voltage, and when it is parallel derived, the output you are seeing low impedance, that is you are seeing voltage. Okay. Transconductance, that is output is current and input is voltage. So when output is current, it is series derived. When input is voltage, it is series fed. So when it is series fed, input impedance is high. When it is series derived, output impedance is high. Trans resistance, that is voltage shunt. That means output is voltage and input is current. Output impedance is 0 and input impedance is 0. It is parallel fed, parallel derived circuit. In common collector, amount of feedback is 1. If closed loop gain is greater than open loop gain, the type of feedback is positive. So AFB is equal to A by 1 minus A beta. Bandwidth increases, that is F2 is equal to F2 into 1 by A beta. And what is the lower cutoff frequency? F1 by 1 plus A beta. That is the lower cutoff frequency. So upper cutoff frequency increases, the lower cutoff frequency decreases. So bandwidth is F2 minus F1. So in a negative feedback circuit, what is happening? The bandwidth is increasing. In negative feedback amplifier, rise time is reduced due to increase in bandwidth, because rise time into bandwidth is constant. So that's all for this session. More in the next session. Thank you. Thanks a lot. I wish you all the best.